Hello. This is section 2.4, using linear models, day 1. So we are going to talk about modeling real-world data. Linear equations are useful in modeling many real-world problems. A scatter plot provides a visual of two sets of data and is useful in determining whether there is a linear relationship between the data sets. So remember, when we are talking about something that is linear, we are talking about a line. And it's helpful to remember usually the most useful form of a line, the equation we use would be y equals mx plus b. So in word problems, it's a little bit different when we're talking about these equations. In word problems, m stands for the slope still, but we call it the rate of change. And then b is still where our graph crosses the y-axis, but it's also now called our starting amount or our beginning amount. So those are two helpful things to know when we are trying to solve these problems. So for the first problem, it says a candle is 6 feet tall after burning for 1 hour. After 3 hours, it is 5.5 feet tall. Write a linear equation to model the height y after burning for x hours. So when I'm taking a look at this equation, I would ask myself, do they give me the rate of change and do they give me the starting amount? So looking through this, I can tell that nothing's talking about how the rate at which the candle is burning or how tall the candle is. So that means that instead, for this problem, they gave me 2 points. So that's the first thing I'm going to do. I'm going to write down the 2 points that they gave me. And as I'm writing this down, you guys should write the same order as I do and write everything down so that you have it as a useful tool to help you while you're doing your homework and things we're doing in class. So the points that they gave me, it says a candle is 6 feet tall after burning for an hour. And notice in the problem that it says height is the y after burning for x hours. So that means that our independent variable, which I'm going to write up here, is always our x, which in this case stands for hours. And our dependent variable is our y, which in this case stands for the height. And we're talking about the height in feet. So, of course, this is a very big, tall candle, so I had to get my boyfriend to help me bring it home to my house. So for this, now that I know my independent and dependent variables, I can go ahead and write my points. So the points that I have for this, so if it's 6 feet tall after 1 hour, that means that my x would be 1 and my y in this case would be 6. So that would be my first point. So then the next point that I have, it says after 3 hours, it is 5.5 feet tall. So that's point number 2. So 3, 5.5. If I want to find the equation of the line that goes through these 2 points, well, then the first thing I have to find is my slope, because if I'm looking at y equals mx plus b for the equation for my line, I need my slope and my y-intercept. So first things first, find the slope. And if you remember, how do you find the slope of an equation? We've already talked about this, y2 minus y1 over x2 minus x1. So in this case, my slope is going to be 5.5 minus 1 over 3 minus, and I actually just wrote that down, it's 5.5 minus 6 over 3 minus 1. So when I simplify this, I get negative 1/4. So remember, this is my slope, and remember, slope is rise over run, So what does this mean? I have, and I always like to write this out too, so this means I have my height versus or over the number of hours. So this basically means that for every our height, so we're just decreasing 1 foot per every 4 hours. So that's the rate at which our candle is burning. So for number 3, now that I have the slope, if I want to find the equation of this line, what's the most helpful if you have a slope and some points? We're going to use point-slope form. So does it matter which of the 2 points that you pick? No, you can pick either the 2. So I'm going to pick the one without the decimal because that looks a little bit easier. So I have my slope, which is -1/4, and it has to go through the point 1, 6. So remember, point-slope formula is y minus y1 equals m times x minus x1. So now I have to just go ahead and plug in my numbers into the formula. So y minus y1, so this is x1 and y1. So y minus 6 equals my slope, -1/4, times x minus x1, which is 1. So I'm not finished yet, so the next part I want to do is just go ahead and solve this and put it into slope-intercept form. So in order to do that, we have to distribute this 1/4 to each of those terms. So we get y minus 6 equals -1/4 x, and -1/4 times -1 gives me positive 1/4. And then I'm running out of room, so I'm going to write this over here again. So y minus 6 equals -1/4 x plus 1/4. So then the next part I need to do is add 6 to both sides. And of course, if you have trouble with those fractions, you can go ahead and use your calculator, which is what I would practice doing. So y is equal to -1/4 x, and 1/4 plus 6 gives me 25/4. So this is the equation given those 2 points. So the equation of the line. So let's go ahead and take a look at some of the questions. So those are the steps, again, that I would always go through even before I answer the questions if I'm given 2 points. So number 1 says find the slope of the prediction equation. What does this represent? So why do we call this an equation, a prediction equation, which is also sometimes called a trend line, is because it helps us predict things for the future. So we can plug in for x the number of hours that we want, and we can use that to help us predict what the height would be after that many hours have gone by. So our slope, in this case, we already found, which is m, is equal to -1/4. So if we write this in words, this means that the candle burns at a rate of 1 foot per 4 hours. So 1 foot every 4 hours. And again, because remember, it's rise over run, so height is in your numerator and hours is in the denominator. So all you need to do is just put it into words. So now we know how fast our candle is burning. So then for question number 2, it says, find the y-intercept of the prediction equation. What does this represent? So the y-intercept is easy to find because remember, when we have y equals mx plus b, that's our b value, which we found right here. So I know in this case the y-intercept is 25/4. And I'm going to go ahead and put that in a decimal form. Normally I like to keep it as fractions, but if we're talking about a word problem, it's okay to do that. So we're going to put this as 6.25 feet. So what does this mean, our y-intercepts? Remember, in order to find the y-intercept, you're plugging 0 in for x, And remember that 0 stands for then the number of hours. So in order to put this in words, I would say when time equals 0, the original height of the candle is 6.25 feet tall. So that means that's how the height at which we started at before we lit the candle and it started to burn. So number 3 says find the prediction equation. So this is, again, easy. We've already done this. Our prediction equation is y equals negative 1/4 x plus 25 over 4. And again, sometimes instead of calling it a prediction equation, it's also called a trend line. Or sometimes it's also called a linear model. So I'm going to write that down over here. So also called, because I'm running out of room, linear model. So all of those things mean the same thing: prediction, equation, trend line, linear model. So for question number 4, it says predict how tall the candle will be after 5 hours. So if I want to predict how tall the candle is going to be after 5 hours, well, I have my equation. Hours is my x variable, so that means when x is equal to 5, we are trying to figure out what y is equal to. So I just need to go ahead and plug that into my equation. So I'm going to do some of this work off to the side. Y is equal to negative 1/4 times 5 plus 25 over 4. And of course, you guys should practice plugging this into your calculator so you can get the correct answer. So when I do this, I end up with y is equal to 5. And so if we put this in words, this means that after 5 hours of burning, the height of the candle is going to be 5 feet tall. So after 5 hours, the height of the candle, I'm going to erase this so that we can write that in. So the height of the candle is 5 feet. And that makes sense because if you think about it, remember we said the rate of our candle was burning at a rate of 1 foot per every 4 hours. So if our candle starts at a height of 6.25 feet, and after 5 hours we have the height of the candle is 5 feet. So now that I have all of this information, I'm going to use this in order to help me graph it. So I'm going to go back up here to my graph. So it's really important when you're graphing these to make sure that you are labeling everything. So I'm going to go ahead and erase some of the stuff that I have here so that I can better label my graph. So I'm going to erase this stuff over here. So you keep yours on your paper. Okay. So we always want to label our x and y axes. So remember, x is going to stand for the number of hours, and the y stands for the height in feet. And so the next part that I need to do, which can sometimes be tricky, is I need to figure out a scale that I'm going to go by on my graph. So I know this is going to start here at 0. So usually what I do for the y-axis, we notice that our candle is starting at a height of 6.25 feet. So I can go ahead and just make my scale go by 1. So this is going to be 1, 2, 3, 4, 5, 6, and then so on. And then if I look at the rate at which my candle is burning, I know that for every 5 hours it's going down 1 foot. So if I think about that, I know it's going down at a very fast rate. So something that usually helps me figure out what I should do my x scale by is finding my x-intercept of the equation. So I'm going to erase some more of this, and we're going to find our x-intercept to help us figure out what the scale should be on the x-axis. So the x-intercept. Remember, in order to find the x-intercept, you plug 0 into y and solve for x. So we're going to do that into our equation. So we have 0 equals negative 1/4 x plus 25 over 4. So then I'm going to subtract the 25 over 4 to the other side. And then when I do that, I get negative 25 over 4 equals negative 1/4 x. I have to get x by itself, so if it's being multiplied by negative 1/4, I want to divide by both sides by negative 1/4, or I can do the same thing as multiplying both sides of my equation by negative 4. Oops. And when I do that, I end up with an x-intercept is going to be equal to 25. So if I write that out, my x-intercept is 25, 0. So what does that mean? That means that it takes 25 hours for my candle to completely burn. So given that, I don't have enough spaces on my graph to go up to 25 because it's a small graph. So I'm going to do my graph. If I try to do it by twos, I would have 2, 4, 6, 8, 10, 12, 14, 16, and that's probably not going to work. So let's go ahead and go by fives. So this is going to be 5 here, 10, 15, 20, and I can stop at 25 because I know that's going to be my x-intercept. So for this next part, I just want to go ahead and graph it. So I already know what my y-intercept is. I know it's 6.25, so it's a little bit more than 6. And we just found our x-intercept is 0 or 25, 0, which would be right here. So then again, of course, on your paper, you're going to get your ruler out and we're going to connect the dots. And since I don't have a ruler, I'm going to just see if I can try to make a straight line. Okay, and so this is what my graph would look like. Now, this is one of those special cases where I wouldn't put arrows on the ends of my graph like we normally do because I know that I can't, my candle after the height is 0, I can't have a negative height, and I also can't have negative hours, so this is how I would draw my graph. And one last thing that we didn't do is normally it's a good idea to come up with a name for your graph. So since we're talking about a candle burning, I'm just going to call this a burning candle. So we're going to do some more of this in class, so make sure that if you missed something, go back and watch the video again. Make sure that you have everything written down, and we will do some practice problems for these.